continuing my posture correction software journey and adding to my goal to create a model that will help improve posture correction from a sitting position and be able to be used by many people as well as myself. So firstly, I advanced with Always AI facial recognition software. From my last digital narrative onward, I took that software and I advanced it to a human pose estimation model. So as you can see, instead of recognizing a face, it is now recognizing points on my face after recognizing that I'm a human. And within those points, it is mapping my ears, my eyes, my nose, my collarbone, as well as my shoulders. These are very important key points as is said in the output. Additionally, there's also a warning message that says lean back, providing advice due to the fact that I'm leaning forward in this image. So why is this important? Well, I conducted a series of tests through a series of images that I will present to you that prove not only the need for a new model, but also the fact that what could be improved within that model in order to create a better machine learning estimation of a human's posture so that they may better be able to correct it. So there's a few key things to see here, not only the image, but as well as the error message on the left, as well as the inference time. The inference time has been optimized as this is a starter application that Always AI has provided, which I've been using. But in creating my own model, I will make sure to keep that inference time in account. So within the first image, we see a side view where I am leaning my head forward and it says lean back. This is a very standard posture for me, and as such, it was slightly surprising, but also made a lot of sense due to a level of basic kyphosis that can be visible within the image. Then within this image, it is a front view where I'm having to very clearly strain my head forward in order to create that same lean back message that I had in the previous image, a trend that will be seen through the next few images as well. Within the next image, the error message is lift up your head, and this occurs when your ears end up becoming above your eyes, as is seen in the image, due to the fact that your head is too far down, which would occur if you're too close to your computer screen. And from a head-on view, I'm having to do this with so much strain that some of my shoulder heights are also increasing, as you can see with the left shoulder there, or my right shoulder, that is increasing. And then from a side view, from me just simply using my phone on my desk, I am able to trigger that warning. And finally, for the slump, which was the most difficult position to create, from a head-on view, I had to very visibly raise my shoulders in order to create that image. Whereas from a side view, I was able to use the computer significantly more naturally while still also creating that slump message. So what exactly are the implications of this initial testing? Well, as is seen through these six images, the side view greatly improves the accuracy. And this is due to the fact that during the head-on view, I am requiring additional strain due to the fact that the camera is not as able to create an image of the depth of the points that it is mapping, those very key points. And additionally, it is creating an unnatural position when I'm trying to indicate a slump. Now, the main reason for that is due to the way that webcams work and how much of my face and shoulders they're able to show. And so there's actually a medical reason as to why it is not able to diagnose a slump as well as it should be. This means that to increase the effectiveness of the program, I need to integrate better analysis of the lower back posture, which I'll be discussing shortly, as well as improving the head-on accuracy, which I can do most effectively by creating a better side view, something that I've been able to do in the past few recent days. So as is seen through this image, we can see that the left caption corresponds to a webcam image, similar to the ones that I was taking, that would map from the upper head to the collarbone. And as can see from that angle, despite lower back misfiguration, a webcam would still indicate correct posture, since the head is aligned correctly. And this is due to the fact that due to kyphosis, your back is actually self-correcting and trying to keep your head upright, as that is the most natural part of your body. So for the upper back, the cervical spine is inspected within the current application. And this is due to the fact that through the inspection of the ears and eyes that I have currently, it is able to directly prove whether or not your neck is up or down. However, due to the attempted self-correction of kyphosis that I just mentioned, um, your lower back can actually be misfigured and a webcam would not be able to catch this. And as such, would also lead to the creation of humpback. as is seen through the kyphosis, the middle box right there. And as such, the application must try to tackle that very kyphosis, which I have a medical plan for, which is utilizing the stomatognathic system. Within my recent research, I found that the key to unlocking the lower back is to the stomatognathic system. And this is due to the fact that the mandibular, which is the combination of the lower jaw and the upper jaw, have a direct effect on the lumbar spine, aka the lower spine, as is seen through the image on the right. And as such, a more formed jawline is would not indicate kyphosis or would not indicate misfiguration of the lower back. However, a worse jawline, as is seen to the rightmost depiction, would indeed show kyphosis, the humpback, as well as um, a convex lumbar spine. As such, in order to correct a forward head posture, we can utilize the jawline in order to better diagnose whether a human is currently having correct or incorrect posture. And so this would still fall within the boundaries of the webcam. So what I'm planning to do is to take my current posture algorithm that is seen to the image on the right and combine it with a more detailed facial mapping that will allow me to have points for the jawline and utilize those points of the jawline to make inferences about the lower back. So even when they're not visible within the webcam, it can be diagnosed whether or not the posture for the lower back is correct or incorrect. Now, the platforms with which I'm planning to do this is Always AI, the platform that I used for my machine learning starter application. I can do a model training toolkit within Always AI to create my own model. And additionally, I will utilize mobile phones in order to create a better side view, um, in order to create a much better image mapping for my model. And so this is seen as I've just in the past few days been able to implement this. And this is by using local hosting and through so when I create an Always AI application and when I run it, it runs on a local host. It runs on my local machine. What I'm now able to do is by creating a camera setting within my code, I'm able to cycle through a series of webcams, including my MacBook FaceTime HD camera, or switching that to an app called EpoCam that will allow me to utilize my to mobile phone to take a video of me, and it still allow me to do these machine learning um, uh, computations as is seen here. So I have a stand which is holding my phone and is recording my face here. So as you can see on the image at the bottom, I can be at a very natural posture and it will more correctly diagnose whether or not my posture is correct or incorrect, where the head leaning down is seen in the upper image. So this is not only going to help improve the accuracy, but also make my life a lot easier in creating that model training. Now, how will I make my own machine learning model using the Always AI model training toolkit? I will have to, first of all, collect data. So the image on the right is from a tutorial, which shows that I can create my very own streamer for data collection. I had thought of using famous datasets such as the COCO, COCO dataset. However, those provide still images and often of objects rather than humans. And as such, by creating my own dataset, I can have more relevant analysis to create my model. Then I will annotate that data. Specifically in annotating that data, it would create points and lines similar to the model seen before. And finally, training that model. So using the Always AI Mac desktop application, I would be able to create a graph similar to the one on the right, and utilizing that graph, continue to fine tune my model until I'm able to monitor that status. So the reason that uh, I would use transfer learning in this would not use transfer learning in this case, as is said in the image, is due to the fact that I would not be using a dataset similar to these COCO dataset, which is taking still images, but rather analyzing a video streamer. And as such, the model that I would be using would be slightly more tweaked for my purposes. Finally, in for my other ideas to improve the application, while the application is running, such as it actually has been throughout this entire presentation, um, as can be seen right here, I could have it basically whenever I put my head down, it would sound and audio that would say, lift up your head, you are leaning down, and this is causing double the pressure on your cervical spine and neck, because currently it is playing a very standardized sound. So basically, the most important thing to be taken away from this is that through the changes I've done by creating a mobile webcam, I've been able to take the load off of my computer as well as create a more accurate depiction. Now, in order to create the most accurate application that I could, I will utilize whatever I need for a stomatognathing system and utilize that in order to create the most accurate posture correction software for sitting posture that is currently available out there.